Okay, I'm covering 2-9, which is absolute value functions. We're going to learn the basic graph as well as transformations of the parent function. This is 2-9. Oops, went a little too fast here. So we had these in Chapter 1. I'm going to review them and give you a little bit more specific type of instructions. All right, so these are transformations, and I want to review these. Horizontal shift, so you're moving along the x-axis. So the rule is f of x changes to f of x minus h. So that means you're going to replace x with x minus h, where h is your horizontal shift. So if h is greater than 0, you move right. If h is less than 0, then you move left, which means in your equation, a positive value is going to mean a left shift, a negative value is going to mean a right shift. We'll see that later. Vertical shift moves up and down the y-axis, and as it says here, the rule is f of x gets replaced by f of x plus k. So you take the function equation and you add a k to the end of it, and then simplify if you can. If k is greater than 0, you move up. If k is less than 0, you move down. All right, so reflections across the y-axis. So remember, reflection across the y-axis is going to make your x values change. So the rule is f of x goes to f of negative x, which means you're going to replace x in your equation with a negative x. Reflection across the x-axis is a change in your y value. So you're going to negate the whole parent function or function equation. So the negative goes on outside of the function, and you may have to distribute that negative. And I think the most confusing of transformations are horizontal and vertical reflection or compressions and stretches. And I call them all stretches. It just happens that if your stretch is a fraction, then it's going to be a stretch of a fraction as opposed to a compression. But if you choose to call a factor less than 1 a compression, that's fine as well. So horizontal stretch, that's going to change how your x value is growing, essentially. So what it tells you, if you have a stretch factor of b, your equation is going to change by 1b over x. So you're going to replace x in your equation with 1 over b times x. b greater than 1 is a stretch. b between 0 and 1 is a compression. Vertical stretch, it's going to change how fast your y value is growing. So if you have a stretch factor of a, you just multiply your equation by a. And again, stretches of greater than 1, stretch factors greater than 1 are actual stretches. If they're between 0 and 1, they're a compression. Note, y-intercepts don't change on a horizontal stretch or compression, and x-intercepts don't change in a vertical stretch or compression. Something just to keep in mind if you're thinking about graphing. It might help you figure out if you've done the right thing. Right, so an absolute value function is a function whose rules contains an absolute value expression. Graph of the parent is just f of x equals absolute value of x. The actual graph looks like a V with a vertex at 0, 0. So here's the parent function. And basically you've got two lines. This one has a slope equal positive 1, so you're going to go up 1 over 1. This one ends up having a slope of negative 1. So you're going to go down 1 over 1. And I say that, and here's a table of values. Negative 10, negative 5, 0, positive 5. You can see why it looks the way it does. But when we make certain transformations, it's going to involve changes in the slope. So it's going to help you to know what those slopes are. And that's what this says. Absolute value parent function is composed of two linear pieces, one with a slope of negative 1, which is going to be this piece, and one with a slope of positive 1, which is going to be this piece. So we can perform transformations on absolute value graphs. And here is the rule for horizontal and vertical stretches. The transform function is going to be f of x minus h for a horizontal translation. For vertical, it's going to be f of x plus k. So let's look at a little bit more closely what that actually means. Whoops. Trying to get this there. Perform a transformation on f of x equal absolute value of x, then graph the transform function. 5 units down. So this is a vertical. So remember, the vertical shift is f of x goes to f of x plus k. So the actual equation is just going to be, oh, it's down. Yeah, so it's down 5, so it's going to be a negative 5. So this is the actual transformed function equation. For shifts, it's really easy to translate or transform the graph. Here's our parent function graph with a vertex of 0. The only thing we've done is shift everything down. So all you need to do is shift your vertex down to negative 5. And then remember, these linear functions, they don't change. It's going to have, this one's still going to have a slope of up 1 over 1. This is going to have a slope of up 1, or actually down 1 over 1. So you've got these 2 points. So really the only thing you need to do is translate your new vertex and then create your 2 lines with your slope of 1 and negative 1. You can always use a table as well, so if you wanted to create some values, negative 10, etc. So negative 10, this is going to be positive 10, so it's going to give you an absolute value, or a y value of 5. So you can make a table of values, but if you understand how to translate your vertex, it makes it very easy. Okay, 1 unit left. So left means we're going to have an h equal negative 1. So we're going to have f of x, well, f of x equals f of x minus h. So that means we're going to put in our negative 1 inside our function. So that means we're going to have x minus a negative 1. It goes right inside the absolute value function, which you can see that's the difference between our vertical change and our horizontal. This vertical change is outside the boundaries of absolute value. Horizontal is going to be inside the boundaries. So a negative of a negative, this becomes our transform function. How do we graph it? Well, the only thing we did was move this vertex left 1, so I'm going to move it left, and then our sides look exactly the same, up 1 over 1, up 1 over 1, and draw our lines. So you just really need to translate your vertex and draw your sides. Okay, so you should write the rule and make the graph for a 4 units down of an absolute value function. And then also, hopefully you did that, 2 units right. Okay, so let's look at a different kind of transformation. Oh, where am I? Oh, we're going to start with the vertex. So it's kind of what I told you just a few minutes ago. Translate your vertex, and that kind of translates your whole graph. Vertex of an absolute value function. So the graph of g of x equals absolute value of x minus h plus k is the image of the parent function after it's been translated h units horizontally and k units vertically. So it gives you a new vertex at hk. So I think we're going to be working backwards on this. To translate f of x equal absolute value of x, so the vertex is at negative 1, negative 3, and then graph it. So that means this is going to be our h, this is going to be our k. So we're going to have f of x equals the absolute value of x minus, and our h is negative 1, and then my plus k, which is negative 3, which is equal to the absolute value of x plus 1 minus 3. So that's our new function. What does it look like? Well, we're going to have our vertex now, instead of at 0, 0, it's going to be at negative 1, 3. And we haven't done any compressions or reflections, so we just draw our sides by going up 1 over 1, up 1 over 1, and drawing our linear graphs. Okay, I think that was next one. You're going to do the next one, so you should try and translate the function with the new vertex at 4, negative 2, and then graph it. All right, now we're going to do reflections and stretches and compressions, so hopefully you remember those rules. Perform the transformation, then graph. Reflect the graph, and there should be a period there. F of x equals x minus 2 plus 3 across the y-axis. So first of all, look, we have f of x minus h plus k. Our h is going to be here, and this is our k. So that means we have a vertex at 2, 3. So we've moved it right 2 and up 3. So right 2, up 3. We haven't compressed or stretched, so we're just going to find our 2 points, our slope of 1 and negative 1. So here's our positive slope, here's our negative. Okay, then it says reflect across the y-axis. So all we want to do is move this point the same distance from the y-axis over to the other side. So obviously that is directly across, and then we can draw our 2 points, find our points and draw our 2 lines and get our new graph. Okay, stretches I think are the hardest because it's going to affect the slope. So stretch the graph of f of x equals x minus 1 vertically by a factor of 2. So first of all, we don't have an h, but we have a k is equal to negative 1. So basically we're going to move our vertex down by 1. And the rule for a vertical stretch is f of x equals a times f of x. So we're going to multiply our equation by our stretch factor, which is 2, and that's what they've done here. So we distribute this, and that gives us 2x minus 2. So that means that our original graph has been translated down to, so our new k is at equal negative 2. And look what happened to our sides. This multiplication actually multiplies our slope. So our new slope is going to be 2 times the old one, which is going to be 2 and 2 times the negative 1, or negative 2. So you can see we go up 2 over 1, up 2 over 1 to get our points to draw our sides. So the stretches and compressions change the slope of the absolute value graph. Okay, I think I have one more example. Compress the graph x plus 2 minus absolute value of x plus 2 minus 1 horizontally by a factor of 1/2. So again, if we have f of x, or f of x minus h plus k, we can see that our h was a negative 2, since this is now positive, and our k is going to be a negative 1. So we've moved left 2 and down 1. So here's our... So a horizontal stretch is going to be f of x equals f of 1 over b times x. So our b is 1/2. 1 over 1/2 is equal to 2. So basically we're going to replace x with 2 times x. And that's what we've done here. So we've replaced x with 1 over 1/2 times x, which is 2x. So we still have our vertex at the same place, but again, this multiplies our slope. So our slope is now 2 times what it was, so it's going to be 2 times 1 and 2 times negative 1. So that's where we go up 2 over 1, up 2 over 1. And that gives us a horizontal compression. So you can kind of see the horizontal compression looks a lot like our vertical stretch. It looks like a vertical stretch of 2, and in fact they are pretty much the same thing. All right, here's one for you to try. Reflect the graph of the absolute value of negative x minus 4 plus 3 across the y-axis. So be careful because we have, let me move that there, we have a reflection already, so you're going to reflect the reflection. So be careful. All right, so that concludes transforming absolute value functions. Please bring questions to class, and this is your homework.